Okay, we're going to look at the UK climate and kind of what it is as a case study of a climate in your local national scale and the main factors which influence it. So, firstly, I think if you're going to have an answer, you could have a 7, 8, 10 or 40 mark question on the UK climate. I think to start off your answer, it's important you have an idea of what it is. So, firstly, I think the important thing to recognise is, what is the climate of the UK? So if we zoom in, now the best answers will have some detail of rough precipitation levels, temperature levels, but the key thing to recognise is that the UK on the whole can be divided perhaps down the line into 4 main zones. So in this instance you've got the east and the west. Now to the east it's predominantly drier. Precipitation levels are lower, partly due to the fact the main wind direction comes from the west. Rain falls mostly in the west, and therefore in the east you are in the rain shadow. That is exacerbated by the fact that the west has predominantly quite a lot of mountains, increasing the amount of relief rainfall. So then in the west you've generally got far wetter environments, and if you can sort of see the difference here in precipitation level, which are the blue bars. You see the blue bars are far higher on the left than they are on the right. The other key difference really is south to north. The south is far warmer, the north is far colder. That's partly due to the latitude. We're about 60 degrees latitude up here compared to say about 50 degrees latitude down here, which is quite a big difference. The UK is roughly 800 miles long, so it really stretches out quite a lot. So I think any good answer about the climate of the UK starts with a recognition of what its climate is, and it should be broken down to roughly those 4 different zones. So once you've given an overview of what the British climate actually is, I think it's important to recognise there are different factors. So the key factors I want to look at today include these here. They include the role of the general circulation model, different air masses, the role of relief, the Gulf Stream and the jet stream. So perhaps the most dominant feature that affects our climate in the big scale, sort of the overarching factor, is this general circulation model. So if you remember this, it's the one that drives dominant biomes, dominant weather patterns globally. So this is perhaps the most significant one from giving us an overall climate. So if you remember, it starts at the equator, where you've got the most intense heating. Air's heated, it rises, causing low pressure, humidity and rain, hence you get the rainforest there. That then drives the first cell, which leads to 30 degrees north where you've got deserts. But the key thing that we're interested in is it drives this, these 2 cells here, the polar cell and the feral cell. And where they meet is roughly 60 degrees north, which, as I showed you in the last slide, is roughly the top of Scotland. Here you get rising air where the cells meet. You've got low pressure, so therefore it's wet predominantly, and you get forests. Hence you get, at these kind of latitudes, you know the normal climate, the normal biome is a temperate forest. We've cut most of them down, but if you look across to Siberia, Canada, which is similar latitudes, it's just temperate forest. So I think it's important to recognise that in the big picture, on the large scale, in terms of our overall climate, this is perhaps one of the most significant factors. Now this will change depending on the location of the intertropical convergence zone, which changes due to the tilt of the Earth. But essentially, wherever these cells are meeting, that you get what they call the polar front. And the polar front is essentially a line of depressions, which the jet stream brings over from the Atlantic, which bring those depressions, so that's wet, windy, relatively humid air. So that is 60 degrees north. Now that normally sits over Scotland, the north of England. When we get hit by big storms such as the St Jude storm of 2013, that was because this part had lowered where the jet stream, this is also where the jet stream goes, and it hit the south of England. In the summer, traditionally, this is all pushed further north, so often Britain misses this. In the winter, this is often pushed further south, hence Britain gets more of this, but I think on a large scale, that's one of the most significant factors. A second factor which has a massive influence on a more day-to-day scale are the air masses. And this is really significant, particularly if you look at day-to-day, week-to-week weather. Our prevailing wind is from the southwest, which mostly brings tropical maritime air, which is relatively warm but wet. That will also bring across depressions. Hence, the west coast of the UK is wetter than the east coast. So if you get a wind from the southwest, you get that. If you get a wind from the southeast, you get this lovely warm dry air. Sometimes you'll get this in summer particularly, and it'll blow up from the Sahara, and you'll see a coating of sand, really fine sand on everything, and that's literally Saharan sand that's blown up all the way from North Africa. We can also get, these can dominate particularly the northeast and the northwest of Scotland. These can dominate, so you get a polar maritime air mass. This is a cold but wet air mass, usually brings snow, hence the northwest coast of Scotland gets hit by a lot of snow. Arctic maritime and polar continentals, again, they're bringing relatively cold weather. Now you want to recognise that these air masses will influence different parts of the UK mostly. So obviously the southwest is mostly controlled by this one, the northeast this one, the northwest that one. But obviously at different times of the year, so winter for example, whenever we get, if we're going to get snowfall down in Bath, it means that the polar maritime air mass is dominating us. But obviously you know that it's a fairly rare occurrence, which shows how infrequently that occurs. So I think it's important to recognise that on a local or a day-to-day scale, these are perhaps the most significant factor affecting your climate. Okay, so the next one we wanted to look at then is perhaps the role of relief, and by that I mean the mountains of the UK. So I'm just going to zoom back onto this map to show you. Now the key thing here to recognise is that the UK has fairly significant mountain ranges. You've got Dartmoor and Exmoor, you've got South and North Wales, the Lake Districts and Scotland. Where you get these mountain ranges, particularly when you get an air mass coming from the west, which is wet, you get relief rainfall where the air is pushed up, it cools, condenses and rains, and as a result of that, air masses coming from the west, the rain will occur here, here and here, leaving the east of the country significantly drier. So it's really important to recognise, I think, that the relief of the UK massively influences where the rain falls or where it doesn't fall, and because obviously it forces the air to rise and cool, the temperature as well. So again, on a local scale, for certain parts of the country, the relief plays a really significant role in its weather. Right. Next one then is the jet stream. So this is a map from the Met Office of the jet stream. The jet stream blows over from North America. So this, essentially, the jet stream marks the boundary between those two top cells from the general circulation model, and that's the point, essentially this is the point where you've got the warmer feral cell and you've got the colder polar cells where they're meeting. You get this boundary. Now this can kink, this can move in all sorts of different directions for a range of different factors, but the key thing for us is that if it's coming from the north, it's going to bring in air from Greenland, it's going to bring very cold air down to us. If it's coming from the south, it's going to bring far warmer air. This, wherever this hits, will massively influence the weather. So in this, if you look at this one here, this is the UK here, you can see it's hitting the south of the UK. Now this is what happened when the St Jude storm hit. This is hitting surprisingly low, normally it's far higher. If this hits the south of the UK, it's going to bring those winds, those depressions across and hit the south. Whereas usually we'd expect this to be hitting further north, really off the top of, off to the north of Scotland. If this goes to the north of Scotland, you're going to get those depressions passing north, hits the UK obviously there. So where the jet stream hits us will bring that really intense weather, and that's often what brings our really significant storms. So it's worth being aware that this can shift and move, and the weather it brings over, depending on the kinks, can really affect the weather we experience here. And often the good forecasters now can recognise how it's moving, because it moves at hundreds of miles an hour, and the kind of weather it's going to bring from America across to here. The last factor to mention is probably the Gulf Stream. The Gulf Stream, very simply, is the warm water coming over from Gulf of Mexico. This is fairly constant, although perhaps is most significant around October time, where it can really warm up, particularly the southwest, but the whole of the UK. So ultimately what you've got there is a range of different factors. The nice thing is these are all factors which are transferable to any location on Earth, but obviously for this spec you need to have a specific example of the UK weather and climate. The best answers will recognise the scale or magnitude of the different factors. So some factors will have a greater impact on a large year-to-year scale, some factors will have a bigger impact day-to-day, some factors will have a local impact, some factors will have a perhaps a national impact. I think the best answers will recognise the differences in that and bring in examples. So I've talked about St Jude's Storm, things like that. That is a synoptic link to something else in the unit. Cool.